Hello everyone, this is the second video on 1.1 properties and use of materials. In this video, I'd like to cover the second box here about nanomaterials. Nanomaterials are substances that contain particles in size range 1 to 100 nanometers. And what you need to be able to do is to suggest uses of materials, including nanomaterials, given their properties and vice versa. So you may be given the use of it and then talk about what property we are looking at and utilizing. Okay, so in nanomaterials, well, let's talk about what it means by nanomaterials. So as it was just mentioned, nanomaterials are the particles which in size between 1 to 100 nanometers. What do we mean by nano? Nano means it's 10 to the power negative 9. Okay? So 1 nanometer equates to 1 times by 10 to the power negative 9 meters. On the other side would be in 1 meter there are 0.000000000 nanometers. So 9 zeros after 1. Micro is another word that you'd hear. 1 micrometer means there are 1,000 of nanometers. So 3 less zeros either way. But yeah, what I would like you to know is that 1 nanometer is 10 to the power negative 0. Like what you see in the diagram above here. So nanoparticles are considered to be around like graphene or ions and other molecules. Carbon nanotubes, DNA, they're all nanoparticles. Something goes up to carbon nanotubes, proteins, I mentioned that, didn't I? Proteins, nanowire, virus, a bit bigger there, CMOS device, something that would sit in an electrical chip, and also bacteria and some other cells. That's around 10 to the power negative 4. So that's much bigger than nanometer. Sorry, 100 nanometer, because 100 nanometer would probably be around 10 to the power of negative 7 then. Yeah. So anything that's before viruses, they are considered to be nanoparticles. And if it's, I guess, man-made, or it doesn't have to be man-made, but if it's a material that we can use for something else, like nanowire, carbon nanotubes, they are nanomaterials. There's a link for scale of universe, or you can Google scale of universe and scroll around in that environment. You would have used that in year 10 in Earth and Space Science to compare your size or something small to the size of the universe, the observable universe. That's the biggest thing that we have in this universe. So yeah, you can see that if you look at that. All right, now nanoparticles can come in various forms. It can come in solid, liquid, or colloid. Now, you may not know the definition of a colloid, but colloid is where all the particles are suspended around in the medium that things don't usually dissolve into. Hope that makes sense. So think of oil and water. They don't mix usually, but there are certain things that allow there's certain, I guess, situation where oil is homogeneously dissolved in water, or water is homogeneously dissolved in oil. Yeah. So that's colloids. So particles are fairly small, so they don't sink at the bottom. So particle size-wise, we are looking at 1 to 1,000 nanometers. They're too small to sink, so it escapes the gravity's effect, really. So it can be suspended throughout the medium. For example, natural colloid would be milk. So it comes out naturally from animal's breast, and yeah, it's got water mainly, but fat is suspended around it. There's a binding agent, I suppose, to suspend the oil in water. Now, synthetically, you can make colloid as well. Mayonnaise, for example, is where you mix vinegar, which is water-based, and say olive oil. You mix that with egg yolk. Then you can make mayonnaise. Water or oil, either way, is suspended thoroughly within each other, so you can have a mixture there. So colloid is, yeah, part of like mixture. But that's synthetic colloid example. Chocolate is the same. Skim milk is also the same. It's all not artificial, synthetic colloids. Nanoparticles, second point, have a surface area, high surface area to volume ratio. Imagine a basketball and you call that as one particle or particle of something. Basketball is one particle as it is, and it has got surface, but the only outside layer is available for, say, reaction, and it's got certain property to it. Now imagine that you fill the same volume with something smaller, like, I don't know, ping pong balls, table tennis balls. In the same space, you can fit more of the ping pong balls. So naturally, ping pong balls itself will have higher surface area to the volume that it would occupy. Hope that makes sense, or you can even draw what it looks like. Now, this property of, physical property of nanoparticles will allow people to use it for different purposes. Okay, so how this may lead to unusual properties and to a diverse range of use. Now, this is one point that we want to discuss. So, think of something. Think about why having large surface area to the volume would be different from, say, things like basketball size particles. You can find a text in the textbook page 172 to 175, and you can start making a summary about it. Now I'll stop there because I want you to try doing that as homework, and we will share what you found through those pages.